Medium. Except for this is looking strange.
Alright, so the 22G is sampling with and without replacement. You've got sampling with and without replacement. Heavy? Medium. You can get your stopwatch if you haven't already. So we talked a little bit about independent and dependent events last week. I think it was Wednesday when we did section E. So this is going back and sort of combining section E with our tree diagrams. So one thing we talked about for E.1, so this kind of goes with E.1, if we sample with replacement, that means those events are independent. So if we are replacing something, that means you put back what you take out. So if I think back to, my favorite starburst example, if I am, picking out 2 starbursts out of a bag, and my first one is a pink one, if I'm trying to figure out this probability with replacement, I have to put it back before I actually choose the second one. I know it sounds weird in relation to starburst, but that's what with replacement is. You take it out, see what it is, you put it back in, and then you take out the second one. And what that does is that the probabilities of each consecutive sample does not change. So if there are 10 pink starbursts in my bag and I take one out, but I put it back in before my second pick, there's still 10. So that's the difference with replacement, is it's the same. And we're going to compare this and look at tree diagrams, this information on it today as well. So then, without replacement has to do with those dependent events. So, like E.2 was about dependent events, and those were often without replacement. So, here's the thing: is that what you've picked out is no longer part of the future sampling. So, if I take out that pink starburst and there were 10, the next pick there are only 9 available. So it changes what's happening in the future. If you do read that you're drawing samples simultaneously, you should understand that that is the same as sampling without replacement. So if I'm taking 2 starbursts out at the same time, I would still treat it as if it's without replacement because I'm not putting the first one back in to get the second one. Well, if that simultaneously, you would still do it in 2 steps. So at first it'd be 1 less, and then it would be another. Well, it would just be 1 less. If you were doing like a third one, then there would be 2 less in there. Okay. And so the probability of the future draws depends on what you drew previously. So like I had said, if I drew a pink one out, there is 1 less starburst in the whole bag, and then also specifically 1 less pink starburst. So we are going to take a look at a few examples. First, we're going to take a look at an example that is actually in the textbook, and then we're going to make a tree by ourselves as well. The next example, like I said, it's coming directly from the textbook, so I don't think you need to write the whole thing down. It is right out of page 588, so if you want to write a note marble example, page 588, that should be fine for your notes. And here's what it says straight out of your textbook. Consider a box containing 3 red, 2 blue, and 1 yellow marble. If we sample the marbles, we can either do this with replacement or without replacement. So we're going to take a look at both, and we're going to take a look at tree diagrams for both and how they are different, and also how the probability is different. So how many total marbles are in this box? 6. Okay. So again, I would not try and scribble this down. The exact same picture is in your textbook. But this is what our tree diagram looks like with the replacement. Now the diagram will look the same either way. It's the numbers that change from with replacement to without replacement. Because when I start out, I have 3 options. I might get a red one, a blue one, or a yellow one. And then when I pick a second marble, it's the same thing, red, blue, or yellow. Now here's the thing, this is with replacement, so these are like independent events. So the first time I got a 3/6 chance of pulling out a red marble, 2/6 to get a blue marble, and 1/6 to get a yellow marble. But here's the thing, it's with replacement. So if I pull out a marble and I say it's whatever color, I'm putting it back in before I pick out a second marble. So all of these are the same. 3, 6, 2, 6, 1, 6, and so on. They do not change because this is with replacement. Are we okay on that part so far? So then the question, what's the probability of pulling 1 blue marble and 1 red marble in that order? And this is with replacement. So that's what's highlighted in green here. Pulling out a blue one and then a red one. So remember from Friday, when we are figuring out this probability, I have to multiply these. So I have to take, and I forgot to align the board. Are all of my notes going to be terrible today, you guys? Oh, come on. What? Guys, I don't know. I felt okay. I don't know. Okay, so I've got 2/6 chance of getting a blue marble, and then 3/6 chance of getting a red one. So in that order, blue first, red second. So I have 6/36, which is 1/6. So 1 in 6 chance of picking those marbles in that order. And again, once I pick it out and I say, oh, hey, this is blue, I'm putting it back in before I'm picking the second one out. That's what it means by with replacement. I'm placing it back in the pool, if you will, back in the box. So the next tree diagram is without replacement. So you'll see it looks pretty much the same. The numbers are changing though. These numbers start out the same because it's still the same box. There's still 3 reds, 2 blues, and 1 yellow. Now the difference is that, let's say I took a red one out, I'm not putting it back. It's without replacement. So there are only 5 marbles left. So there are only 2 red ones, there are still 2 blue ones, and there's only 1 yellow one. But again, there's only 5 marbles left. Now if I take out a yellow marble, then there's only 5 marbles, and 3 of them are red, and 2 of them are blue. So it changes that. Keep in mind that, remember that the branches have to add up to 1, like we talked about on Friday. So if we go back here, 3 plus 2 plus 1 is 6, so 6, 6 add up to 1. 2 plus 2 plus 1 is 5, 5, 6 add up to 1. So, is that just a refresher from yesterday with that one? Not yesterday, Friday. And remember, if you don't like the fractions, I don't care if you're using decimals, that's fine. So if we answer the same question, what's the probability of pulling 1 blue marble and 1 red marble in that order? Again, we have that highlighted in green. So to get a blue marble on the first pull, there's 2 in 6 chance. And then if I get a blue marble, I'm keeping it, it's not in there. So then to get a red one, there's 3 and 5. So I end up with 6/30, which is a 1 in 5 chance of this happening in that order. We are going to come back to the marble situation for the stat box, but we're going to go to a different example about candy for a minute. Are we okay? Alright, so we are going to take a look at this candy dish here, or it might be a bag. It's a bag of candy. Yep. Consider a bag of candy that contains 5 Milky Ways, 8 Three Musketeers, and 4 Snickers. Draw a tree diagram that represents drawing 2 pieces of candy consecutively. So taking one out and then taking another one out. You'll notice it says with replacement and without replacement. So we are going to be making 2 different tree diagrams. So when I start and I take that first one out, what are my options? Very good. So let's use M for Milky Way. Let's use S for Snickers. What should I use for Three Musketeers? T. And then my next choice is still going to have the same 3 options, where it could be Milky Way, Three Musketeers, or Snickers. Now, both of these are going to look the same. It's the numbers that are going to be the difference between the 2. I don't want to get started on the probabilities for the branches until you guys all have like the framework done. So I'm gonna just kind of keep an eye out. I feel like I might be getting slightly better at tree diagrams. I don't know what you guys think. But my second one has been worse all day though, for some reason. I don't know why. How many total candy bars are in this bag? All right, 17. So that means on my first pull, I have a 5 out of 17 chance to get a Milky Way, 8 out of 17 to get a Three Musketeers, and 4 out of 17 to get a Snickers. On this first tree diagram, if I get Three Musketeers, that's my favorite. The thing is, it's with replacement. So I put Three Musketeers back in the bag before I get my second pick. So these numbers are going to be the same throughout. 5, 17, 8, 17, and 4, 17. Because again, every time I take one out, I'm just taking a look at what it is and I'm putting it back in before I make my second selection. Are we good on with replacement? Can I go to without? Or are you guys not quite ready yet? I'm seeing some nods. I can go. All right. So the first part's the same because again, it's my full bag of candy with all 17 candy bars. So 5 17ths for Milky Way, 8 17ths for Three Musketeers, and 4 17ths for Snickers. So then it gets a little bit challenging. So if I take one candy bar out, how many candy bars are left? 16. So all of these in this section are going to be over 17 or over 16. The thing is if I take out a Milky Way, there were 5, now there'd be over 4. So that'd be 4/16 for Milky Way. There's still 8 Three Musketeers, that would be 8/16. And there's still 4 Snickers, that would be 4/16. It doesn't hurt to just kind of quick add them up to make sure they add up to 1. 4 plus 8 plus 4 is 16, so 16/16. Then I can move down to another branch. So again, they're all going to be over 16, but these numerators are going to be different. Because if I take out 3 Musketeers, there's still 5 Milky Ways, so that'd be 5/16. There's 1 less Musketeer in there, so that is 7/16. And there's still 4 Snickers, so that'd be 4/16. So then if I end up with a Snickers first, again, there's only 16 candy bars left, but there's 5 Milky Ways, there's 8 of the 3 Musketeers, but then there'd only be 3 of the Snickers left. We are going to use these to do probability on the next example, but are there any concerns about how we get these numbers? Okay, so here's kind of how we connect this stuff with section E. So determine the probability of getting 2 different candies, and we're going to do both ways. Actually, I'm going to do with replacement, and then I'm going to let you guys do without replacement on your own. So the thing is, and we did talk about this on Friday, I have to take a look at all of my different options here. So, for example, I've got a lot of different branches that will give me 2 different pieces of candy. Like, I could get Milky Way and a Musketeers, or Milky Way and a Snickers. I could get Musketeers and Milky Way, and so on. So I have to multiply the branches together, but then add all the separate branches. Like, multiply the one branch, but then add all the separate branches. So I'm going to first do Milky Way and 3 Musketeers. So that is 8/17, not 8, sorry, that's 5 if I start with the Milky Way. 5/17 times 8/17. So that's this branch. But then I have to add it to, let's do Milky Way Snickers. So I'm just trying to color code it here. 5/17 times 4/17. So I've got that branch. And then I've got to add it to, okay, Musketeer, 3 Musketeer and then Milky Way. So 8/17 and 5/17. 3 branches down. Can you guys tell I've got 3 more to go? Okay. So I'm gonna keep my adding going on down here. So then I've got, well, I could get a 3 Musketeer and then a Snicker. So that would be 8/17 times 4/17. Alright, got that one. Then I can go Snicker, Milky Way. So that's 4/17 and 5/17. And then last but not least, a Snickers and then a 3 Musketeers. So 4/17 times 8/17. So you have to multiply those all and then add them all up. Do you guys remember the multiplying and the adding step from Friday then? So like half of you that were here on Friday. So then when I do all this, when I multiply and add them up, where are my notes here? I end up with, losing my notes. Oh, here. 184 over 289. Now I want you guys to take a couple of minutes and answer the question without replacement. You're going to end up following the same branches that I did, but you're going to have different values because if I get a Musketeer and then or no, a Milky Way and then a Musketeer, it's going to change that number. I'm not putting the candy bar back. So let's take a couple of minutes to calculate that. We'll kind of go around and see what answers you guys are getting. If you're not getting the right answer, then we have to look into it a little bit more. How do you So if you are not coming out with 23/34, then we need to go back and look at your work, make sure you did all the right branches, make sure you typed it in your calculator right. That's another thing to just, be careful about that. Like if you're doing your assignment, obviously check your answers, and if it's wrong, go back and check your work. But like if you're on a test or a quiz, just make sure you're being very careful and aware of what you're doing. Are there any other questions? Okay. So then back to that marble example for a quick second. If we're drawing marbles without replacement, why can't we have a yellow? Yeah, there's only one. So you could have 0 fifths written here, but also 3 fifths and 2 fifths add up to 1 whole. So it makes sense that would just be 0. Okay, that's it. Here's your assignment for 22G.